go over graphing transformations of sinusoidal waves. So sinusoidal waves are all the possible answers of trig functions. So usually either sine or sometimes they'll put cosine here, but they're both essentially waves, and we'll talk about what they look like, but that's the general idea, cos being just a little off of the sine, so they're very, very similar to each other. Now, when we're talking about transformations, one of the transformations forms that you guys might be used to is like vertex form of a quadratic, right? And this is the vertex form of a quadratic. They usually write an h and a k and an a. And those relate to our sinusoidal function, except instead of having squared, because that would give you a quadratic function, they give you sine, which gives you a wave like that. So let's kind of look on a graphing calculator the difference between those. If we have x squared, you have that, which is a different function. And then if you have sine x, well, this is a wave function. So very, very different. But all of those rules for transformations are the exact same. It's our k value on the outside here is still vertical stuff. Okay, vertical transformations. The h are horizontal transformations, so moving the whole thing. And a deals with stretches and compressions and flips of the function. Okay?
Vertical, right?
Yeah, all vertical still.
And the
So,
K, so the K would be...
Yes,
okay.
exactly. So right now what we did is I just pulled the h and the k over. But in a sinusoidal function, and you can technically write a k in here for quadratic, but it's not really needed. It doesn't really help. It doesn't make huge differences. So in a sinusoidal function, there's something known as horizontal compressions and compressions and stretches and flips. So the h is now the d letter here. So the d letter is the horizontal shifts. The k, the vertical stretches, is now the c. They've renamed k, or they rebranded it. Okay, and it does horizontal stuff that A used to do. So we'll kind of write them out. A is vertical, still exact same stuff, stretches, compressions, and flips on the x-axis. C is, I'll get orange out here. C is vertical movements, so plus is up and negative is down. Okay, that still makes sense. D is what the H used to be, and that's horizontal movements, where a plus, if it's a plus value here, it's going actually in a negative direction, and a negative value is going in the right direction. And then K is stretch, is compressions, and flips on the y-axis, but all horizontally. Okay, so everything within the function, just like this square, just think of this like as within. Everything within sine is horizontal, and everything outside of it is vertical. Okay, but this can be kind of hard to graph. So I'll quickly show you what they kind of look like when we put them all together. So if I put the letter A here, let me give it 2 brackets, x minus d plus c. So this program asked me to add some sliders. Okay, so it's still the exact same idea. Here's when A is 1, and you can see as we increase A, it gets stretched. Okay, so it gets taller and taller, and as the value comes down, eventually it gets to a negative and flips, but the negative looks really similar.
Yeah.
Where when A was on a quadratic, okay, you'll see that a negative, and we'll kind of show them together, when it goes back to positive, it completely flips it. So very different looking, because this one is has so much symmetry to it, the sinusoidal wave. It's hard to tell that it's been flipped, where a quadratic is very obvious. It's going down the other way.
Yeah.
Okay. So that's when we deal with the A movements. Okay. The K movements. K movements have to do with increasing the period. So the horizontal compression there, and then you're going to get a horizontal stretch. So it's same idea as A, just the other idea. And then that was the flip when it went negative. So again, because there's so much symmetry, it's hard to tell that these events are happening as we go through it. Okay, so let's put K back to 1 here. Okay, and that's with that K value was the number 1. D is horizontal movements, so that would be similar to, I'll put D in here. This is normally what we called the H function before, but the D, you'll see that everything's moving to the right or everything's moving to the left, right? So similar to a quadratic, all these movements are the same, it's just a very different function that we're using, okay? And then same idea, this used to be like the K value with a quadratic, but it's C, and C has to do with vertical movements. It's up and down. So very, very same, very, very similar stuff. The only major difference is we usually don't deal with K in a quadratic, and that has to do with stuff moving back and forth. Now, these things can be relatively hard to graph by hand. So we're going to try to graph one of them by hand. So let's kind of set this up here. We're going to attempt to graph this one here. So the very first thing we're going to do is kind of lay out what's the A, the K, the D, and the C here. And as long as they're pretty much written in order, so it's obvious that this would be the A. Now this value in here is the K. This value here is the D. And finally, the last value is our C. Okay, so now that we know what the numbers are, we have an idea of what they're going to do in the graph. And when we talk about what they're doing in the graph, we have to say in reference to something, right? Otherwise, you can't say you're stretching to of nothing. You have to say in reference to something. So we have to know how to actually graph this original one. This is sine x, okay? So it'll be helpful if we have a couple coordinates kind of memorized, okay? So if you were to put in a calculator, so we can go to the other side here. If we put into a calculator, where's my sine? Sine, there it is. Oh, it all crashed. Let's go back. Nope, that's not gonna work. Let's try this one. Yes, okay. Sine 0, and you get the value of 0, okay? So what that means is when x is 0, y is 0. So that's one of the coordinates here, right at the origin, okay? Let's try the next thing. What about if sine was, let's say, 90 degrees? Delete. Sine is 90 is equal to 1. So when x is 90, we have a y value of 1, okay? So this is a way you can kind of go about figuring out all the coordinates. We'll do a couple more quickly. If we had 180, that equals 0. So we know that we're at 0. So 180, y value is 0. If we have 270, and these are all, I'm choosing major ones. You could choose all the numbers in between these. You get -1. These are the common 5 major ones. So at 270, we're at -1. And then finally, 360 again is 0. And then this pattern repeats. So
that next one would be like up there?
Yeah, it would just continue, keep going. There you go. So we're just going to make a connection of the wave. Now, if I wanted, I could have gone to our calculator and we could have decided to put, maybe the number 60, right? So let's put 60 in. And it gets us a small decimal, 0.8. Well, on our graph, 60 would probably be around here, 0.8. Yeah, that makes sense. But it's easier if we just memorize these 5 major points, right? And then the pattern continues. So because this is going up, it would probably go there. Since this is going down, at 90 would be -1, at negative, up, down, down, like that. And we just kind of connect a wave, right? So this would be considered your sine x. This is the original one, okay? You can choose to make any of these movements first. I would suggest probably dealing with the A and the K first, just because they're going to be easier to stretch when they're along the axis and flip, rather than if you move everything 90 degrees and down. It's going to be hard to stretch and flip things after. So first thing we'll say is our A value. Our A value is 2. So what we do is we're going to take every y coordinate we have. Okay, so here's all our y coordinates. We have 1. Our major y coordinates are 0, 1, and -1. And we're going to multiply those by the value of 2, because A is equal to 2. So we're going to take all our y coordinates and multiply them by 2. Okay, so 0 times 2 is still 0. Yeah, still stays 0. So at points at the exact same spot. 1 times 2 is 2. So now it goes much higher. 0 times 2 is 0 again. -1 times 2 is -2, 0. Okay, so now, I'm only going to do one movement at a time. But you'll see that this is much more stretched. It's been pulled farther. And then you can kind of continue that pattern. It goes up, and then this would go down, 0, up, 0, down. So these are considered vertical stretches, and it kind of looks like it's been vertically stretched. Someone's pulled it from the top and the bottom much, much farther. Okay, that's a little bit of an easier one because we're used to quadratics. This is where it gets difficult. K value, okay? The K value is in reference to your x coordinates, so we know K is a half, okay? And actually what you do is you take the x value and you divide it by whatever the K is. So when you divide by half, it's actually the same as multiplying, am I saying K? Sorry, x. It's the same as multiplying x by 2. So we take all of our x coordinates and we're going to multiply them by 2. That's why I chose a half, just so it'd be a little easier to do mentally. So 0 times 2 is still 0, nothing's changed. So here's our next major coordinate. It's at 90 degrees, okay? 90 times 2 is 180. So this y value is now pushed over to 180, okay? 180 times 2 is 360. So that gets pushed way over here. And already we can see that this is being elongated. Okay, it's like it's being horizontally stretched. Okay, and then the same concept is happening. Let's go down on the other side. Negative 90 is 180. 180 is 360. So now we have our horizontal stretch, and I didn't make that very wave-like, but that's what's happening. Now I know this page is getting really messy, but we'll go and show you a final product on the graphing calculator after, right? So from here we're on the blue one, so we should kind of write what we did in here. This is just sine 2 sine x. The blue one is 2 sine x, and then we have a half of x. That's what the 2 one is. So we're slowly adding each of the transformations. And then the last two are relatively easy. If we know our stuff. Positive 90 actually means we're going to go in a negative direction. And we're going to shift the blue one 90 degrees to the left. I should have used different colors. I got my color scheme mixed up here. We've done red, blue, green. Let's use turquoise for horizontal. Okay, that's not going to show. Purple. There we go. That'll show. So we're going to the left 90 degrees. So all that means is we look at all of the x values of our blue one. These are our major points now. Okay. And we're going to move them all 90 degrees. So instead of being at 180, this is at 90. Okay. Instead of being at 360, it's at 270. Instead of being at 0, it's at negative 90. Instead of being at negative 180, we've shifted to the left 90. It's at 270, and this is at 450. So now this should be the same shape as the blue one, just shifted 90 degrees to the left. So does it look like, I know it's hard to see, that it's been shifted 90 degrees to the left? Okay, so the purple one, really getting hard to see, 2 sine 1/2 of x plus 90. And then finally, the very last thing we're going to do, we'll do it with orange, is a vertical translation down 2 units. So we're going to take the purple one, sorry, not down 2, but 1. We're going to take the purple one and we're going to move it, let's get everything on the screen here. No, don't disappear. Too bad. Down 1. So all our major coordinates, this is at 0, it now goes down to negative 1. This is at negative 2, it now goes down to negative 3. 0 goes down to negative 1. This is at 2, it now comes down to 1. This is at 2, at 0, it comes down to negative 1. This is, I don't know where that is, it's probably down here-ish. So let's see if I've drawn this properly. I think it's really hard to see here. We're going to do it on a graphing calculator after. But that is the purple one mimicked, just everything's been shifted down 1 unit. Okay, so it's probably easiest as you go along to erase the old ones because it'll be much easier to see. But we can go to a graphing calculator and kind of go through each of those transformations very quickly. So let's delete all of these. All right, so the original was sine x. So there's our wave. Actually, we're in degrees and this thing's in radians. So let me just fix this a little. Negative 450 and positive 450. Okay. The first transformation we made was 2 sine x. So you can see that it got stretched vertically. So we'll turn the old one off. Okay, so now we're at the blue one. The next thing we did was the horizontal stretch. So we did a half x. And you'll see it got wider. It got horizontally stretched there. So we take that one off, and now we're at the green one. We then decided to shift it 90 degrees to the left. So we go 1/2 x plus 90. And you'll see the purple one has been shifted 90 degrees from the old one. You can see where the peaks are, right? That's a 90-degree difference. So we'll turn the green one off now. And then finally, the last movement was 1/2 bracket x plus 90. And everything went down 1. And you'll see the orange one is y values are down 1 unit from before. So from the original, very, very different. And these are kind of the progression through everything, the orange one being our final copy. Okay?